Okay, chapter 5 on probability. This is your chapter review. Follow along as we do this. I will ask you questions, so please don't fall asleep. Questions 1 through 4 are your vocabulary questions. Instead of a blank, they actually told you how many letters it was, so it's pretty easy. Probability is the number of blank outcomes divided by the number of blank outcomes. Jesse, what's the first word for that? Favorable. Favorable. Did I already make a video of this? I don't think so. And what is the next word, Jesse? Possible. So if you read the instructions, it says take all, for question 5, you need to have these circled red letters. So far we have an A and we have an O. Question 5, isn't it? Okay. Question 2 says the probability of an event occurring based on experimental results is called blank probability. Donnie, experimental. EXPER IMENTAL. N is the next red letter. A blank blank and a table are two ways of organizing outcomes. Colby, tree diagram. TREEDIAR GRAM. So we have an R and a D and an M. Add to our list. And question 4 says rearrange the letters in 1 through these ones here to make one of the remaining keywords. What is the word? Jamie? Random. What a random thing to say. Random. Okay. Question 5 says a toolbox, which is not this, so I'll just erase this here. Different question altogether. A toolbox contains 3 screwdrivers and 2 wrenches. An electrician's helper chooses a tool at random. What is the probability that she grabs a wrench? So if I was to draw this poorly, this is a poorly drawn screwdriver. And there are not one. Thank you. It does look like a lighter. There are 3 screwdrivers in this particular tool, whatever, box. And there are 2 wrenches. That should be even better than the screwdriver. A wrench looks like, oh, I have no idea. Do I look like a handy person? Just ask Mrs. McDonald, and she'll tell you how handy I am. Thank you very much for that. So there are 2 wrenches. So if my assistant reaches into my toolbox and I'm asking what is the probability of pulling out a wrench, what is my possible outcomes as a number? 5. And Kyle, how many of those are wrenches? So what number, we call this 2, what's that 2 called? Favorable outcomes. It's what I'm looking for. It's what my assistant is looking for. He's looking for a wrench, and there are 2 of them in the bag out of 5 possible tools. As a decimal, that would be 0.4. And as a percent, that would be 40%. Why? Because 0.4 is 4/10, and 4/10 is really 40/100ths, and 40/100ths is 40%. Any questions with 5? We're good? Question 6 says melee, or melee. Chooses a card at random from the following deck. What is the probability she chooses a red card? Well, in that picture, how many are red? There are 0 favorable outcomes out of 10 possible cards. That is 0.00 or 0%. There's no chance you're going to draw a red card unless you cut your finger on the card and it bleeds all over it and you think that's a red card. Otherwise, you are not choosing, or you're colorblind. You could think that's a heart upside down. What is the probability of a 3 or a 4? Well, now our possible outcomes is still 10. There are 10 different cards I might draw. Of those, 2 of them, this card here and this card here, are 3 and 4. That is 2/10, which is 20%. And what is the probability of choosing that as a multiple of 3? Logan, how many multiples of 3 are there here? There's 1 for 3, there's 1 for 6, and there's 1 for 9 using my bingo dabber. There are 3 cards out of the 10 that are there, which means there's a 30% chance of drawing a multiple of 3. And the final one, what is the probability of drawing a card less than 7? Jordan, what do you think? What's the probability of drawing a card less than 7? How many cards are there? 10. Okay, so that's going to be our possible outcomes. How many of those 10 cards are less than 7? You have it in front of you. There are 6 cards less than 7. There's a 1, 2, 3, 4, 5, 6. This one's not less than 7. That one's not less than 7. There are 4 cards that are not less than 7, and there are 6 cards that are less than 7. So there's a 60% probability that you will draw a card less than 7. Okay? Any questions on number 6? Pretty easy so far. Question 7 says, a chef. I don't think I want to go to a restaurant where a chef actually does this. I really don't. I don't trust him. I think he's kind of a little off. But anyway, at this chef cafe, the night special, this chef, for whatever reason, decides he's going to spin a spinner and flip a coin to decide what he's going to serve you. And the coin, if the coin, where is it at here? One side says salad, and the other side of the coin says cooked. Right? Heads is going to be a salad, tails is going to be cooked, for example. And then he spins it. So it says draw a sample space. So how many of you did a tree diagram for this, just out of curiosity? Did anyone do a tree diagram? Donnie, if you could put that little spinny thing away. How many of you did a table? Nobody. Just a table. Nobody did a table. 5 people did a table. Nobody did a tree diagram. Interesting. So if I take this, I'm going to put salad up here. I'm going to put cooked over here. And I'm going to put broccoli. I'm going to put beans. And I'm going to put carrots. Now you might have used BR, BE, and C, and salad and cooked. It's up to you. But based on my table, how many possible combinations are there? 6. Okay, there are 6 possible outcomes. Of the 6, Donnie, which one do you not want? Which one would you not want of those 6? Raw beans? How many say raw beans would be their worst, their least favorite? How many say cooked broccoli is their least favorite? Cooked broccoli with no cheese sauce, just cooked broccoli straight up. Raw broccoli. Cooked carrots. Raw carrots. Really interesting. Cooked beans. Well, which color do you prefer? They're the same. How many think green beans and yellow beans are the same? Well, hold on, hang on. I have a question. How many view cooked green beans and cooked yellow beans as the same awfulness? How many prefer one over the other? Of course, green beans are much better. Yellow are better? Yes? Yeah? No, that's pork and beans. That's a completely different story. Okay, question 8. Follow along. At a restaurant, Carrie decides to close her eyes and randomly point to one dinner and one dessert item on the menu. Wow. That's even, she would get along very well at that last restaurant. But what she has here is, I'm going to do a table again. And I'm going to go chicken quiche, grilled fish burger, hamburger surprise, which I hope to God I don't get, and the vegetarian special. And for dessert, we're going to have ice cream sundae and apple pie. How many possible combinations are there based on the table alone? 8. And it says how many dessert, or sorry, this is it here. So these are all the combinations here. This is your sample space right here. How many dessert combinations are there? There are 8. 8 combinations. I would not want the hamburger surprise with, I like both desserts, I don't care. Vegetarian special would be good too. Why do they have to have a surprise in the hamburger? Like, what is this, like a Band-Aid or something awful? Surprise! It's my left finger. I don't know. I don't know. Left ring finger. Okay, a coin is flipped twice. What is the sample space? Draw a tree diagram. So this time it is explicit. It does say use a tree diagram. So for this one, For this one, we are going to draw a tree diagram. So our first event is going to be H and T, and this means I either flip a heads or I flip a tails on the first one. If I flip a heads, these two here show what could happen on my second flip. It could be a heads or it could be a tails on my second flip. If I flip the tails first, my next one could be a heads or it could be a tails again. So there are four possible outcomes. My sample space is heads, 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 tails, tails, heads, and tails, tails. What is the probability of flipping two tails? There's only one chance out of the four possible outcomes that is tails, tails, which means theoretically there's a 25% chance that you will flip two tails if you flip two coins. Okay. What's the probability that you won't flip the same? Is it 3 out of 4? Two chances out of this one and this one are the only two that are not the same. This one and this one are. So you have a 50-50 chance of either flipping the same or flipping different, right? Equal chance. Question 10 says a toolbox contains a hammer, a screwdriver, a pair of pliers, and a tape measure. And a pail contains a nail, 4 screws, and 2 hooks. That's it. It's the saddest pail ever. A nail, 4 screws, and 2 hooks. So sad. What can you do with it? You can't do anything with that. But you randomly choose one item from the toolbox and one item from the pail. So let's look at this. Here we go. Here we go. So we have hammer, screwdriver, pliers, tape measure. And here you have a nail, a screw, a screw, a screw, a screw, a hook, and a hook. How many combinations are there? There are 4 multiplied by 7, which is 28 possible outcomes. What is the probability of getting a hammer and a nail? Well, how many are hammer nails? There's just this one, isn't there? Right? Which is 1 chance out of 28. Now, just before we actually go to the calculate, is there 2 nails? Just nail hammer. 1 chance out of 28. Is that going to be more than 4% or less than 4%? How do we know? What is 4% going to be? 1 chance out of 25. So 1 chance out of 28 should be less. And if we look at the calculator, 1 divided by 28 tells us as a decimal, it's 0.0357. I'm just going to look at this one here. Is that approximately 3/100ths? Which would be approximately what percent? Right. So it's actually 3, and if I want, I can include this as my decimal part. Approximately 3.57%. And what is the probability of a tape measure screwdriver? Well, it depends. If you followed the instructions and it says you take one item from the toolbox and one item from the pail, what's the possibility you grab a screwdriver from the pail? 0. So what's the probability that you reach into the toolbox and pull out a tape measure and reach into the pail and pull out a screwdriver? 0% chance, right? Not going to happen. Not going to happen. Question 11 says describe or draw 2 possible independent events that could be used by this tree diagram. Okay, so here we have it. So here we have 4 boys. We have Joe. We have Pete. We have Kolji. He's from Russia. And we have Damie. Joe, Pete, Kolgi, and Damie. Those are the 4 boys. And we have 4 girls. We have Hasmin. Hasmin. We have Donovan. Donna V. Donna. How good is that name? Sorry. Could be Donna. Let's see. Donna. We have Jessie, of course, that's a good name. And we have Lucy. So this one here, and this 2 here, and this 3 here, and this 4 here. Okay? This could be 1, 2, 3, and 4. This could be 1, 2, 3, and 4. If I'm randomly setting up these 4 boys with these 4 girls, how many combinations of dates could I possibly make? There are 16 possible combinations. Colgi and Donna would be a fantastic couple. They would never stop talking, and they would be. Oh, that's too good. So there are 16 possible combinations. You could do a whole bunch of different things. But question B, what is the probability that both numbers are the same? So we know there's 16 possible outcomes for B. Of those 16 possible outcomes, how many of them are identical pairs of numbers? 4 of them. What's 4 to 16 as a fraction in lowest terms? 1 over 4. What's that as a percentage? 25%. So we could say that the probability is 4 out of 16 that they're the same, or in lowest terms, 1 out of 4, which would be a 25% probability. For question C, what is the probability that the sum, which means adding, of the numbers is 5? Of the 16 possible combinations, I'm going to use a red marker here. This one here, this one here is 5. This is 5. This is 5. And this is 5. Again, the possibility that the sum is a number is 5. It's the same as before. It's 4 chances out of 16, which is roughly 25%. And finally, what is the probability that the number for the first event is smaller than the second event? So, looking at my sample space, this is 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1. So how many of those is the first number smaller than the second number? This one, and this one. This one and this one. This one, and that's it. So for this one, for D, there are 6 combinations out of 16, which if I grab my calculator, 6 divided by 16 as a decimal is 0.375, which is what percent? 37.5%. Okay. Any questions with that?